This is section 3.2 about quadratic equations and problem solving. All right, the first picture that I've got showing here shows that when you have a quadratic, you can have a various number of solutions. At the most, you could have 2 solutions. You might have 0 real solutions, and graphically that looks like this, where you have the parabola, but it does not touch the x-axis. This is where our solutions are. One solution, perhaps it goes up, touches, it goes back down, or vice versa. It could do that over there. But it's just going to touch it one time. That's one solution. And then if you have 2 solutions, it's going to cross the x-axis 2 different places. So those are your 3 options for quadratics and their solutions. You can solve them by a variety of methods, which we're going to talk about in this section: factoring, square root property, completing the square, and the quadratic formula. Let's look at factoring first. It's assumed that you pretty much know factoring when you come into this course, so it's not a teaching of the method, but rather reminding you of what that looks like. So when we're doing this one, we want to think about what are the factors of 1. Well, that one's pretty easy. That's a 1 and a 1. And is it going to be positive or negative? Well, to get a positive here, they've either both got to be positive or both negative. But we need a negative in the middle. So we know we're going to have this. And then each of those small expressions gets set equal to 0. So you have x minus 1 is 0, x minus 1 is 0, x equals 1, x equals 1. And your solution is a repeated root positive 1. Now that looks like this picture here where we went up and hit. So it would be hitting at 1. That's what that one would look like. All right, how about this one? Whenever we solve this one, we want to be sure that it's equal to 0 at the start. So our first thing would be to get this -1 over here. So we would have 2x squared plus 2x minus 12 equals 0. Then we should note that these are all even, and we could divide every piece by 2 to kind of simplify it. That would leave us x squared plus x minus 6 equals 0. You want to think about what are the factors of 6. That's either 6 times 1 or 2 times 3. And which of those combinations could add or subtract to give me 1 in the middle? Well, that would be these 2. So we know we're going to have an x and an x, and we're going to have a 3 and a 2. One of those numbers is positive and one's negative. We need a positive in the middle. So that tells me I'm going to have a plus 3 and a minus 2. Whenever I do that, then I usually check to make sure that I am going to get what I need. Positive 3 minus 2 does give me 1 in the middle, and 3 times negative 2 gives me 6. When I'm satisfied that I have the right factors, then it's x plus 3 equals 0, x minus 2 equals 0. So x is negative 3, x is positive 2, and your solution would be written just negative 3, 2. Okay? All right, so it's a reminder of factoring. The square root property says if you have x squared equals a number, the solutions are plus or minus the square root of that number. So this works nicely when we don't have a middle term, we just have 2 terms. In this case, we have the squared, the t squared, and we have a constant. So let's move this 16t squared to the other side. So now I have 100 equals 16t squared. If I'm solving for t, I want to then divide both sides by 16. So 100 over 16 equals t squared. So now I have that square root property. X squared t squared equals a number. So I'm going to take the square root of both sides. When I take the square root of t squared, I simply get t plus or minus square root of 100 over 16. And the square root of 100 is 10, and the square root of 16 is 4. So I have plus or minus 10 over 4 equals t, and you could reduce that to 5/2. All right, so square root property comes in handy sometimes. Completing the square. We did a little bit of this in changing to the vertex formula. This is a little bit different. We don't have a y here. We have equal to 0, so we won't have a y involved in our work. So remember that the first thing was to get the constant to the other side. So we're going to subtract 9 on both sides. And remember that this is the box method because we have to figure out what we're going to do to both sides. All right, how do we figure out what goes in the box? Half of this number and then square it. So 1/2 of -8 equals -4, and -4 squared is positive 16. So 16's going there, 16's going there. We then rewrite both sides. On this one, we're factoring this. We're writing it as factor. Something squared equals, over here I get 7. And remember here it's x. We match that sign. And whatever the half was, of course, if you're matching that sign, you don't have to worry about that -4 there. All right, now square root property. We're here. Take the square root of both sides. When you take the square root of this, you get x minus 4 equals plus or minus square root of 7. You're solving for x, so you want to add 4 to both sides. So x is 4 plus or minus square root of 7. All right, quadratic formula. Most of you probably have seen it. It is in your packet of information under handouts and in the formulas and models. But this is the formula, in case you've forgotten it. You need to remember that in an equation like this, you want to make sure they're ordered from x squared to x to the constant. And then so this is a is 3, b is -6, c is 2. So let's go ahead and write this down. So we've got -b, so that would be -6 plus or minus square root of -6 squared minus 4 times 3 times 2 all over 2 times 3. This is positive 6 plus or minus square root of 36 minus 24 over 6. 6 plus or minus square root of 12 over 6. Now this expression here can be simplified. You want to rationalize that. So you want to think, is there a perfect square that's a factor? Well, square root of 4 times square root of 3. That does give me a perfect square. This is 2 square roots of 3 then. So when we write it again, we're going to put this expression in for the square root of 12. So x is 6 plus or minus 2 square roots of 3 over 6. And typically in math lab, you're going to see they're going to write this as 6 over 6, which is 1 plus or minus 2 over 6 is 1/3 square root of 3. So that's just breaking that apart. 6 over 6 is 1, 2 over 6 is 1/3. And the last thing that we want to get in our notes is the discriminant. The discriminant is this thing right here, and it should look familiar. It's that part of the quadratic formula that's inside here. Okay, so just the discriminant itself tells you about the roots. If you know the value of the discriminant and it happens to be positive, then that means there's two solutions right here. If it's equal to 0, that means, so if it's equal to 0, that means you're going to have one solution, and it'll be this part. If it's negative, then you have no real solutions. All right, so sometimes your question might be just to describe the roots. You don't solve the problem, you just say, oh, well, I know there's two real solutions or one real, etc. All right, let's look at the problems and see if we can work these and get you some feeling for what that's going to be like. All right, on this one, we're going to complete the square. And so we need a little bit of work room here. Let me give myself a little bit more room. Okay, so I'm going to go ahead and add the one to the other side, and I'm going to put my boxes here. Okay, so we're doing this by completing the square. Move your one to the other side and have your boxes. All right, how do we find out what goes there? Half of 2 is 1. 1 squared is 1. So 1 goes here, 1 goes here. We're going to then rewrite both sides. So I get 2 here. I get something squared here. Now remember, I'm going to do half of that thing that goes there. Then I'm going to use the square root property. Take the square root of both sides. So I have x plus 1 equals plus or minus square root of 2. I'm going to subtract the 1 over. So x is equal to negative 1 plus or minus square root of 2. Now in MATLAB, we don't have this nice little icon here. So it would be in your solution box right here. You're going to have negative 1 plus the square root of 2, comma, negative 1 minus the square root of 2. So that's what you would have for MATLAB. All right. This one simply says solve the following, and it appears that that thing's going to factor nicely because the factors of 10 are 10 and 1 or 5 and 2, and 5 and 2 do add up to 7. So let's write that out. So we have x plus 2, x plus 5. So x equals negative 2, x equals negative 5. And those are the numbers that will go here. Just like that, no parentheses. All right, this one says solve the following quadratic equation. And we're going to do that with the quadratic formula. We could do it either way. Actually, it doesn't tell us to use the quadratic formula. So, does this factor? Let's look at this and see. Factors of 49, 7. So this does factor nicely. So x equals negative 7, x equals negative 7, and it's a repeated root, so when we go up here, we're just going to choose that, and we're going to put negative 7 in one time. All right, solve by using the square root property. All right, it's already in something squared equals a number. So if I take the square root of that, I get x plus 22. And plus or minus square root of 17. I subtract the 22. So I have x equals negative 22 plus or minus square root of 17. And over here, when you're putting in your solutions in your boxes, you'll have negative 22 plus the square root of 17, comma, negative 22 minus the square root of 17. All right, solve this one. Now this one does not factor. There's not going to be factors of 1, which are 1 and 1, which are going to give me this in the middle with this out here. So looks like we're going to have to use the quadratic equation. And let's see, A is negative 3, B is negative 4, C is equal to 1. All right, so I've got Z equals negative 4 plus or minus square root of negative 4 squared minus 4 times negative 3 times 1, all over 2 times negative 3. All right, so that equals 4 plus or minus square root of 16 plus 12 over negative 6. And that's 4 plus or minus square root of 28 over negative 6. And remember, we want to look at this number in the radical and see if we could simplify it. And we can. Come over here. Square root of 28 has a factor that's a perfect square. That's 4. So the square root of 4 is 2. So we've got 2 square roots of 7. We're going to use that instead of square root of 28. And when you get to this, you want to look at this value, and this value, and see if they are all divisible by the same thing. They are, and we could divide everything by 2. So we would end up with 2 plus or minus square root of 7 over negative 3. Now, I think when you go up here to do your answers, you're going to be here. We'll have negative 2 plus the square root of 7 over 3. Negative 2 minus the square root of 7 over 3. And I'll put these over here. All right. Let's look at number 6. All right. So the first part says select the correct choice and fill in any answer boxes in your choice. So we're going to solve this thing. Does this factor? Let's write it out over here. Factors of 54 could be 27 and 2, 6 and 9, 54 and 1, 18 and 3. But the 6 and 9 are going to give me the 3 in the middle. All right. So let's see. I got a 9, I got a 6. Which one needs to get the negative sign? I need negative in the middle. So this is going to be my minus. This is going to be my plus. So I get x equals negative 6, x equals 9. So those two numbers are going to go here, negative 6, comma 9. Complete the table of points below where y equals this. So what this means is I've got these values when x is negative 6 in this equation, y is 0. So they want us to plug in negative 4. So I got negative 4 squared minus 3 times negative 4 minus 54. When you do those calculations, you should get negative 26. So in this box is going to go negative 26. All right, in the other one, let's see, is 6. So we got 6 squared minus 3 times 6 minus 54. And I believe we get negative 36 on that one. Okay. From the table, the solution is. So here we went ahead and factored it and did it symbolically. Here we're looking at the table, and the solutions are the x-intercepts. Those occur when y is 0. So we are looking right here and right here. So we got the same solutions. We're just going to rewrite that in this box, -6, 9. And then we want to pick the right solution. You could throw it in your calculator. You could be mindful of the y min and max of 74. We know it's not this guy. We know it's not this guy. Those are both upside down. So you would just need to make sure whether it was this one or this one. But if you put it in the calculator, you could check that and you should get B. All right, let's look at number 7. A baseball drops from a stadium seat that's 51 feet above the ground. Its height, s in feet, after t seconds is given by. So we have this equation. Estimate how long it takes for the baseball to strike the ground. Okay, so we're making, it's a negative t squared, so we're making this kind of shape. All right, so we've got s of t equals 51 minus 16t squared. All right, so think about, you're talking about t is time, s is the height. Well, we're talking about when is it on the ground? When is it on the ground? There's 2 times when it's on the ground. But what's the height there? The height is 0. So put 0 for the height. And let's solve that. This looks like one that we would solve with the square root property. So I'm going to subtract the 50. Let's add the 16t squared over here. All right. And then let's divide the 16. And then let's take the square root of both sides. So t equals plus or minus the square root of 51 over 16. And I could go ahead and take the square root of 16. That's 4. So t is plus or minus square root of 51 over 4. Now, let's think about, we're talking about time. There are 2 solutions. That makes sense. There's 2 places. But do we need this negative one? We don't have negative time, so we ignore the negative, and we do an approximation. I believe it said to round to the nearest tenth. So if you do this little thing in your calculator, square root of 51 over 4, then t is approximately 1.8. All right, let's look at number 8. Consider this equation and complete the following. All right, so the equation where it's equal to 0. So we just got to reorder that a little bit. And so we have x squared minus 4x plus 4. That'll go in that box. We just added the 4 to the other side. Calculate the discriminant. Well, a is 1, b is -4, c is equal to 4. So the discriminant is -4 squared minus 4 times 1 times 4. All right, so we get 16 minus 16. That equals 0. So 0 goes here. Determine the number of real solutions. And remember, when we learned about the discriminant in the notes, we said if it equals 0, you have 1 real solution. Okay. Solve the equation. All right, so now we're going to need to solve this thing. So if we do, that does factor. So x equals 2, x equals 2. That's a repeated root, and that makes sense because it said, our discriminant told us we had one solution. So it's repeated, and we would choose here and put 2 in the box. All right, let's look at number 9. Same kind of question. Write the equation in that form. So we got to move some stuff over. So we've got 5x squared plus 7x plus 6x minus 28 equals 0. I wrote that really badly, sorry. All right, and I'll make that a little bit cleaner. So we can see that in this box right here, we're going to put 5x squared plus 13x minus 28. Okay, and then it says calculate the discriminant. So we've got A is 5, B is 13, C is negative 28. And so that's 13 squared minus 4 times 5 times negative 28. That's 169 plus, because that's minus times minus, I believe you're going to have a 560. And that should equal 729. So our discriminant is 729. That's a positive number. That tells me there's going to be 2 solutions. Okay, so we do need to solve that equation. All right, so let's do this. All right, now this one does factor. It's a little bit not as clear sometimes. You could do a couple of things to this. You could use the quadratic equation, because that's always going to work. But if you notice that it will factor, then that's fine too. All right, so what I said was the factors of 28 would be like 4 and 7, 2 and 14. Let's see, 4 and 7. That doesn't really jump out at me, but let's think about if we put it in here and see. So that's 20, that's 7, that could give me 13. If I have a plus 4 and a minus 7, that would work. All right, so that gives me x is negative 4. 5x minus 7 is 0, so 5x equals 7, so x is 7/5. So those are my 2 solutions, and I would click here and put 7/5 comma negative 4. All right, and I think that does it for section 3.2.